Okay, let's give you guys some practice. So here you've got a building 80 meters high. Um, the sun is here casting a shadow that is 60 meters long. Okay, so when the sun is over here, it's going to cast a shadow, let's say around here. So you can see here that this theta here is a lot less than a lot less than this theta here. So as the shadow decreases, theta gets bigger and bigger. So at the precise moment in time when this is 80 and this is 60, um, at that precise moment in time when the shadow is 60 meters long, the the rate at which theta is increasing is 0.3 degrees per minute. So later on, you're going to have to convert this into radians. Okay, so the question is, at this precise moment in time when the shadow is 60 meters long, what is the speed of this shadow here? What's the speed of this shadow? So basically, well, that's the question. What is the speed of this shadow when it at the precise moment in time when the shadow is 60 meters long? Okay, so press pause and have a go. Okay, so to do this here, hang on. So to do this here, try and understand what's going on here, because try to find, well, here you've been given d theta by dt, and really you want to know, let's call this distance here x. You want to know dx by dt. So you've been given d theta by dt, and you want to know dx by dt. The height of the building is a constant. It's always the same. Okay, so looking at this here, what connects theta and x? So basically, you want to know dx by dt, and you've been given theta. So what connects theta and x? Well, tan here is what the thing that connects everything is tan. Okay, so hang on. So tan theta equals 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 80 over x here. Okay, so this is a thing that connects everything, because we've got to call it x because x is going to vary over time. Okay, so now use implicit differentiation. Bear in mind that well, theta is a product, or well, is a theta is dependent on time. So theta is a function of time. Um, and then also, as time goes on, x is also a function of time. You see, this 80 here is a constant. So when you use implicit differentiation, differentiate this, that will then give you this. But then because theta is a function of time, then you've got to stick this d theta by dt in here. Okay, and also because x is a function of time, you've got to stick dx by dt in here. So use implicit differentiation. That will then take you to here. Okay. So now you need to know you need to know theta at that precise moment in time. So remember, at that precise moment in time when the shadow is 60, d d d theta by dt was given to us. Okay, hang on. So we are currently here. Okay, let me just scroll back. At the precise moment in time when um, when the shadow is 60 meters long, d theta by dt is given to us as this. Okay, we've got to later convert into radians, but then we also need to know the theta itself at the precise moment in time when the shadow is 60 meters. Okay, so we need to know theta at this precise moment in time when the shadow is 60. Okay, so hang on. So we are currently here, but we need to know the precise. We need to know the angle at that precise moment in time when the shadow is 60. So we need to know theta here when it's 60 and 80. Well, basically tan theta equals 8 over 6. So blah blah inverse it, and then theta is given to us as this. Okay, so now we know theta. So looking at this here, we later, well, don't forget we are currently here. We later need to put this into here, but then we need to know this. But we've got to convert our rate here into radians. So the question when the question was given, uh, d d theta by dt was given as this, but we need to convert this into radians. So hang on. So let's convert this into radians here. So 180 degrees is pi. So if you times by this thing here, then you also times this thing here. Yeah. If you times by this, it will give you one degree equals this radians. Well, if what is it that you need to times by over here to take you to 0.3? Whatever this number, whatever this multiplier is going to be the same over here. Okay. Well, that magical multiplier there would be this. So basically, if you start here and then you times by this, it will take you to here. So that means if you start here and times by this, it will take you to here. Okay. So what that means is 0.3 degrees per minute. If you convert that to radians, it will give you this. Okay. So we were currently here. We now know theta equals this, so we can put it into here, and then we also know the rate in terms of radians here. So this is our d theta by dt measured in radians. So we can now put this into here. Okay, so that will then give us this, and then just punch it into your calculator, and then dx by dt will be given by this. Okay, so what that means is, don't forget, this is a positive direction, and this is a negative direction, meaning 0.65 here is because we are going to the left. If we were going to the right, then it will be positive. So this minus thing here does actually make sense. Okay, so looking at this here, what it means is that at a precise moment in time, when the shadow is 60 meters long, the speed of the shadow is actually 65 centimeters per minute. Okay.